All right, we said Friday. If you have an equation and there are fractions, you don't have to work with those fractions. You can get rid of them by finding a common denominator. But because the denominator has a variable in it, we have to list out any restrictions on y, because we don't want the denominator to equal 0, because then it's undefined. Okay? So before we even start, we need to look at this y right here in the denominator and label the restrictions on it. What can y not equal? All right, now, okay, if we want to get rid of the fractions, we multiply by the common denominator. What is that? It's this and this, okay? Y plus 1 and 3. Now, the whole purpose of this is to cancel out the fractions, okay? So whatever you multiply by one term, you have to multiply by all terms. So what we have left here is 3y. And on the other side, my 3's cancel, so I have to distribute a 2, correct?
Why didn't the multiply what they already have? Like,
For those people who need to make sure they see everything and they don't take shortcuts. Okay? We're multiplying by what's already there because we want to cancel the denominator. All right, if you know it's going to cancel and you're just going to scratch it out, then you go for it. But I want to make sure that everybody can follow and see exactly how we got where we got. What you're saying is a shortcut. All right, so here when I distribute a 2, I get 2y plus 2. This is a regular equation. I can solve it by subtracting 2y from both sides. And I get y equals 2. Now, what did we say y could not equal? We said y couldn't equal negative 1. Well, it doesn't. So your answer is y equals 2. Wow. All right, somebody said number 13?
Yes.
How many terms are in this problem?
2.
3. There are 3 terms. Okay, big plus signs, big equal signs, minus signs by themselves separate your terms. So when I find my common denominator, which is s, I'm going to multiply all 3 terms by s. But what can s not equal?
S.
S cannot equal 0. All right, the common denominator is s, so I'm going to multiply all 3 terms by s. Now, in this first term, that gives me s squared. In the second term, I have 5s. And over here, my s's cancel, and I simply have 6. Now, I said Friday, you need to look at this and say, okay, if this is a squared term, then that means it's a quadratic equation. And how do we solve those? We set it equal to 0. Very good. So we're going to subtract 6 from both sides in order to set the entire equation equal to 0. Now, we can either factor, complete the square, or use the quadratic formula. This can be factored. What are factors of 6 that subtract to give you 5? All right, 3 and 2 add up to 5. We're looking for factors that subtract to give us 5. That's why it's important you need to check. Okay, then we have our zero product property, which says if the answer to this addition problem times the answer to this addition problem equals 0, one of those answers has to be 0, right? Which means if this works out to be 0, then s was equal to what? negative 6. And if this works out to be 0, then s was equal to positive 1. Do either one of those violate my restriction? No. So s was equal to negative 6 and positive 1. Annalise, what's your question?
23.
You don't even know what to ask? Did you watch the video? Go back and watch the video. Okay. All right, 23. E minus 4, E minus 2. The parentheses aren't there in the problem, but you need to understand that those are groups. Now, the reason I'm writing my fractions like that is because I know I'm about to put a bunch of stuff up there. Okay, so I'm just leaving room on my paper to put up when I need to. All right. Step 1 was to make sure there's no factoring that needs to be done in the denominator, which there is none. Step 2 is identify your restrictions. Only on the denominator. What can b not equal? B cannot equal plus or minus 2. Okay? What's next?
Common denominator.
Common denominator. What is it?
B minus 2 plus 2.
If you want to use colored pencils while you're working on this and learning it to make sure that you're seeing exactly what's different, what you're adding up, or not adding, but like putting up there, that might help you. Yes?
Okay, I don't understand what the difference is between this and what was on before. Like where you find your common denominator, put that over.
Okay, because before we had two fractions that we were adding up. Okay? And so we couldn't take those fractions and turn them into whole numbers. I was just adding them. Now I've got an equation. And with an equation, as long as you multiply every term by the same number, you'll still get the same solution for your letter, for your variable. So, in an effort to get rid of all these fractions, I'm using the common denominator to cancel out the denominators. Okay? Because I'm trying to eliminate fractions. I don't have to work with them when it's in an equation. So that's the difference. Yes?
Can you give me an example of when you do
When there's no equation, there's no equal sign. When there's no equal sign and you're just simplifying an addition problem or you're simplifying a subtraction problem. Okay? But when it's an equation, anytime you have an equation, you can do anything to it to make it easier for you to solve. If you've got decimals, you can multiply by multiples of 10 to make it easier. Fractions, you can multiply by a common denominator to make it easier. Just equations or inequalities. Okay? All right, here, the b minus 2 terms cancel, so I have to multiply b minus 4 times b plus 2. Which ultimately gives me this.
That's FOIL.
That's FOIL. Right. I put my two middle terms together in my head. All right, here, b plus 2 cancels, so I've got to FOIL b minus 2 times b minus 2.
Why wouldn't you put b minus 2 twice?
Because the only time you have to list it twice as a common denominator is if it appears twice in a single fraction. Okay? I just need enough to cancel out this 1 here and this 1 here. All right? You'd still get the same answer. You'd just be in higher terms, and you'd have some simplifying to do at the end. Okay, here, whenever I do FOIL, I have b squared minus 4b plus 4. And here, b minus 2 cancels, so I have 1 times b plus 2. Okay? I'm going to stop here and let you catch up.